Hello and welcome back to Instant Seekh. मेरा नाम है कृष्णा कहार. In this video, we will be continuing with our Maharashtra Set Computer Science PYQ series. आज का ये वीडियो कंप्यूटर साइंस सेट 2024 PYQ का पार्ट 4 वीडियो है, जिसमें हम कवर करेंगे क्वेश्चन नंबर 76 से लेकर क्वेश्चन नंबर 100 तक. So let's start. You can join our Telegram channel. इस वीडियो इस PYQ के डिटेल सोल्यूशन और एक्सप्लेनेशन एज अ PDF will be uploaded on our Telegram channel. So do join that channel for such notes and PDF as well. Okay, so let's start with the questions. Okay, so question number 76, what it says, which of the following is not decidable? What are the option given? First of all, we will see the options. First is given a turning machine M, a string S, an integer K, M accepts S with K, step S. Second is equivalence of two given turning machines. And third is language accepted by a given DFSA is non-empty. And fourth is language generated by CFG is not non-empty. Okay, so let's see one by one. एक एक options को हम देखेंगे. Okay, यहाँ पे पूछा क्या है, which of the following is not decidable, meaning it should be undecidable. Okay, so if we see the last option, language generated by CFG is not empty, this can be determined. Okay, this is decidable. Option number 4 is decidable using what techniques? Reachability and generation checks. Okay, so this is not the right answer. Okay, next, C, DFSA is not empty. We can check for final states. Okay, in DFSA we can check for final states. Okay, so it is decidable. Okay, so this is not the right answer. Let's see the option S, option A. It is also decidable. We can simulate M with K steps. It is a bounded process. Okay, we can simulate the first tuning machine, that is with M for K steps. Okay, so it is decidable. So this is also not the right option. So your right option is equivalence of two given Turing machines. Okay, this is undecidable. Okay, so your right answer is answer number B. Answer B. And why it is so? Because this is undecidable problem. No general algorithm exists for this particular concept. Okay, so your 76 answer is option B, that is equivalence of two given Turing machines. Let's move to the next question. Determine the language by the following deterministic finite acceptor. Okay, we have given a set. Okay, that is A comma B. Let's see the options, what it states. Okay, you can visually go through the diagram. Okay, now what the language will be accepted. Okay, first option is a language that recognizes the set of all strings, that is starting with the prefix A comma AB. Okay, next, option B, a language that recognizes the set of all strings starting with AB. C, all strings starting with A or B. And D, a language that recognizes the set of all strings starting with any number of AS. So first of all, if you observe the diagram, okay, so what it states basically is, here if you see, we have something AB. Okay, so using this we can directly identify option number C, starting with any number of A and S. This is wrong. Option D is wrong, because we will be selecting those language, okay, those are starting with at least AB. Okay, so this is clearly wrong. Next, C, if we see a language that recognizes starting with A or B, okay, this is also wrong. We are looking for AB, right? Now there might be the confusion between option A and option B. Okay, so what we have is, okay, what we have is a language starting with AB. In option B, if you see, a language starting with AB, and in A option it is starting with prefix AB. Okay, this is not the same. Okay, you might get confused in these two options, but it is not the same. The correct answer will be answer A, that is starting with prefix AB. Okay, so the language that will be recognizing all this set of strings should be starting with prefix AB. So your right answer for this particular question is answer A. Let's move on to the next question. Okay, now which of the following is the characteristics? Question number 78 we have, which of the following is the characteristics of recursive descent parsing? Okay, so options are given: backtracking, memoization, ambiguity, shift, reduce, conflicts. Okay, now let's see one by one. Now shift, reduce, conflicts, we know it is usually belongs to what? Bottom up parsing. Okay, not decent parsing. Ambiguity is not a proper grammar, it is not a parsing behavior. Okay, parser behavior, right? Next we have what? Backtracking, right? And memoization. So your right answer is answer A, that is backtracking. Okay, why? Because the recursive descent parsers use backtracking unless optimized. Okay, so memoization is basically used for bracket parsing, not recursive descent. Okay, this memoization is not used for recursive descent. Okay, so this is wrong. Okay, so your correct answer is backtracking. That is your answer number A. Let's move on to the next question. Okay, question number 79 we have, in a S attributed definition, what distinguish synthesized attributes from inherited attributes? Okay, so options are given. You might find the option similar. Okay, the first option is synthesized attributes. Attributes are computed bottom up and inherited attributes are computed top down. Next, inherited attributes are computed bottom up and synthesized attributes are computed top down. Next, C option, what we have, inherited attribute depends on synthesized attributes, and option D we have synthesized attributes depend only on inherited attributes. Your correct answer for this particular question will be answer number A, that is synthesized attributes are computed bottom up and inherited attributes are always computed top down. Okay, so your right answer for this particular question will be option A, that is synthesized attributes are computed bottom up and inherited ones are computed as top down. Okay, so let's move on to the next question. Okay, next we have question number 80. In peephole optimization, what is loop unrolling aimed at achieving? Okay, we have seen peephole. Okay, you might have learned about peephole optimization. So it is asking what is loop unrolling aimed at, why we use it basically. So options given are option number A, reduce the number of loops. First option is reduce the number of loops. Second, eliminating conditional statements with loops. Third, decreasing the size of loops by removing redundant instructions. And fourth, D is expanding the body of a loop to reduce overhead and improve parallelism. So this is your right answer, that is answer option number D. Okay, so in peephole optimization, loop unrolling is used for expanding the body of a loop and reducing the overhead and improve the parallelism. Okay, so your right answer for this particular question is answer number D. Okay, let's move on to the next question. Okay, question number 81, what we have, the dash is a program that runs on computer and servers that allows computer to communicate over a network. Okay, basic question, isn't it? Okay, now what it is asking, a program that runs on computer as well as servers and that allows computer to communicate with the network. Okay, will it be system software? So first option, no, it won't be the system software because it rely on this located on a includes utilities, or you can say located on a local system where you use OS utilities. Okay, not specifically for networking. Now application software, will it be used for networking or kind of communicating with the other networks? No. Windows operating system, no, this is too specific to a particular platform. And last one is the right answer, that is your network operating system. Okay, so your right answer for this particular question 81 is network operating system, that is used to allow the computer to communicate over the network. So option D is your right answer. Let's move on to the next question. Determine, okay, now we have a PCM TDM system question. Okay, determine the line speed for a 20 channel PCM TDM system with 8 kHz sample rate, 10 bits per sample and 1 framing bit per frame. Okay, So since we have given a sample, okay, so we have how many bits, how many channels? We have 20 channels. And what is the sampling rate? It is 8 kilohertz. Okay, so each channel, so first of all we will write what each channel is communicating. Each channel, what is the frame rate that is going on? 800 samples per second, 8000 samples per second, 8000 samples per second. Okay, and if we multiply by this into the bits, okay, what is the bit rate per sample? 10 bits per sample. How many bits? 10 bits per sample. Okay, so it will be 8000 into 10, that is 80,000 bits per second. Okay, so now we have for each channel how much bits per second we are having. So for each channel we are having 80,000 bit per second. So since the number of channels are 20, okay, just a second. Okay, sorry. Okay, since each channel has now the transmission we know is 80,000 bits per second, so we can estimate for 20 channels it will be simply what? 80,000, okay, one more zero, into 20. Okay, that will be equivalent to something 1.6 Mbps. 1.6 Mbps. Okay, now, but this is not the right answer. You can't find the options. Okay, what options we have? Okay, we have 1.608, we have 1.204, 3.406 and 1.2 Mbps. Okay, okay, you can from here straight away you can mark option A as the right answer because none other option is nearby. But one more step is there. We have to add the framing bit, one framing bit per frame. Okay, so if we add that particular one framing bit, okay, so one framing bit means we have total 8,000 framing bits. Okay, and if we add this to our speed, that is 1.6 Mbps plus 8,000 bits, then bits per second, then you will be having your answer as 1.608 Mbps. Okay, so this is how you calculate the line speed for the 20 for this particular question. Okay, so your right answer will be answer A, that is 1.608 Mbps line speed will be there for this particular channel. Okay, so right answer is answer A. Let's move on to the next question. Okay, so the next question is, in dual cable system, to transmit a data, a computer outputs the data on to cable 1, which runs to the device called the dash at the root of the cable tree. Okay, so now it is regarding to the cable system. Now tail end, we have, what are the options we have? Options are tail end, after one hop, head end and round trip. Okay, so first option, let's see the options one by one. Tail end, tail end is the far end of the cable. Okay, it is what? Far end of the cable, can't be the root. Okay, so option A is incorrect. Second, after one hop, this is basically not a node, it is a timing reference. Okay, so this is also not the right answer. Head end, yes, this is where all the cables coverage is responsible for broadcasting signals. Okay, your head end is responsible for all the cable coverages. Okay, and also you can call the root. So this is the right option or your right answer for this particular question. And round trip, if we see the option, it describes data flow, it is not a hardware component. Okay, so your correct answer is option C, that is head end. Okay, Okay, as you can see, tail end opposite of head end after one hop, not a control point. Round trip describes the journey. It is not a hardware component. Okay, so head end is the main control center. It receives the data from the computers and send over the network. Basically, it is responsible for all the coverages. Okay, so your right option is option C. Next, what is the broadband frequency in telephone networks? Okay, options are 4 kilohertz, 3 kilohertz, 2 kilohertz, and 1 kilohertz. Okay, let's see the options. First, D, 1 kilohertz, it is very low, insufficient. This option D. Okay, option D, 1 kilohertz is very low. So this is not the right answer. 2 kilohertz, it is also very low. Okay, for voice clarity. 3 kilohertz, baseband. This is suitable for baseband, not broadband frequency. Okay, so your right answer is 4 kilohertz. This is used for what? In telephone network as a broadband frequency. Okay, so your option A is your right answer, that is 4 kilohertz. Next, in wireless networks, CDPD stands for, okay, simple basic definition, okay, abbreviation. Question it is, what does the CDPD stands for? Option A is given, it is a carrier data, packet data. B, collision detection in packet data. C, cellular digital packet distribution. And D is cellular digital packet. Okay, so your right answer is D, this one, that is cellular digital packet data. Okay, CDPD stands for cellular digital packet data. That is option number D is your right answer. Let's move on to the next. Which device is used to connect different networks that provide necessary translation both in terms of hardware and software? Okay, and what are the option givens? Switches, routers, hubs, and gateways. Okay, so you should be very clear these networking component or the functionalities of each and respective networking components mentioned in this. This is very important with respect to networking system. Okay, these are the basics that you should know. So let's see one by one what each of them are used for. Switches are used for what? Connecting devices within the networks. Okay, routers connect similar networks using IPs, and hubs are used just to broadcast the data, no translation or routing. Okay, so your gateway is your right answer. Your gateways, D, is your right answer, that connects different types of networks and translate the protocols for the transmission basis. Okay, so option D is your right answer. Let's move on to the next question. Let's see the next question, that is question number 87. What is the bit pattern obtained for the sequence of bits? Bit pattern is given 10110101 was sent in even parity by adding a bit at the end. Okay, so after adding even parity, what was the bit pattern it is asking? Okay, so first of all we should write the pattern given 10110101. It is saying that it was sent in even parity, and we should know in even parity always the number of ones is even. Okay, let's count the number of ones, how much it is. Total it is 5. Okay, 1 2 3 4 and 5. Okay, so to make it as an even parity, we need to add one more 1 at the end. Okay, so now the new bit pattern or sequence will be 10110101, and last we have added 1 for making it as a even parity. Okay, so this will be our pattern that was being sent. Let's see which of the option matches this particular pattern. So your option A matches this particular pattern, that is 10110101 and 1. So your right answer for this particular question is option A. Let's move on to the next question. In computer networks, pulse code modulation method is used for digitizing analog voice signals using usually samples. The incoming voice signal once every dash microseconds. Okay, so it is asking in PCM, that is pulse code modulation, what is the voice incoming signal every microseconds? Okay, what is the rate at which rate it is coming? Okay, you should know the standard sampling interval. Okay, the standard sampling interval that we have, or you can say the sampling is done at 8 kilohertz. 8 kilohertz is the sampling done. Okay, and sampling interval, once if you do this, what is the sampling interval? So the sampling interval will be 1 divided by 8 kilohertz. We will be converting it into 8000. Okay, and the answer that we will be getting if you divide this is 125. Okay, that is 125 microseconds. Okay, so PCM, your PCM usually samples with what? At 125 microseconds. Okay, your right option for this particular answer will be option number B, that is 125 microseconds. Okay, here if you see, I have solved itself. Standard sampling rate equal to 800 samples per second. 1 second equal to this. Okay, 10 lakh microseconds. Okay, if you divide the 10 lakh microseconds by 8000, you will get 125 microseconds. Okay, so option B will be your right answer. Okay, let's move on to the next question. Okay, question number 89. What is the fixed size block used by trivial file transport protocol to transfer the data? Okay, this you should know. Okay, what is the fixed size block size in TFTP, that is trivial file transfer protocol? Okay, so the correct answer is 512 bytes. Okay, the correct answer is 512 bytes. This is a fixed size block that is used in TFTP to transfer the data. Okay, others are wrong. Okay, so your correct answer for this particular question is option number C, that is 512 bytes. Let's move on to the next question. Okay, so we have 90, question number 90. What are the highly stable and highly volatile values that are assigned to the information in time to live field? Okay, now here two things, highly stable and highly volatile values are asked for what? Time to live field, for TTL field. Okay, so highly volatile value is 1 day. Sorry, highly stable value is what? 1 day. Okay, and 1 day is around 86,400 seconds, and highly volatile is 60. Is what? 60. Okay, you need to remember this. Okay, highly stable is 1 day, that sums around 86,400 seconds, and highly volatile and is 60. Okay, so your correct answer for this particular question will be option A, that is 86,400 will be highly stable value, and 60 will be the highly volatile value for time to live field. That is option number A is your right answer. Okay, you can see 80 is 1 day is highly stable value, and 60 seconds is the volatile used for dynamic or for fast updating the records. Okay, so this is regarding TTL values in DNS. So your option A is the right answer. Let's move on to the next one. Okay, now in list, question number 91, in list, the function that provides the initial element of a list is. Now you should know libs, what the libs is. Okay, now one by one we will see the options. List initially returns the first element using which function? Okay, so set is used for assignment. Let's see the option number B. This is used for assignment. Okay, not for list accessing. Second, this returns the second element, not the first, as it is saying. And first is used in different entities. This function is used in different entities, not in list. Okay, so your correct answer is car, CAR. Okay, see a classic LISP function. LISP uses the function CAR function. Okay, to return what? To return the initial elements of the list. So your correct option for this particular question is answer option A, that is car. Okay, let's move on to the next question. In neural network, question number 92, in neural network, the network capacity is defined as the traffic TRA, capacity of network, the total number of nodes in the network. Option C, the number of patterns that can be stored and recalled in the network. Option D, the number of computes in a network. Okay, so it is saying out of this capacity, in how the network capacity is defined in neural network. Okay, so the traffic does not define the capacity of the network. First of all, total number of node also not doesn't define the capability or capacity of the neural network. Number of computer, that's about physical system, not the neural network or neural learning. Okay, so the number of pattern that can be stored and recalled defines the neural network capacity. Okay, so your option C is the right answer, that is the number of patterns that can be stored and recalled, or you can say the network's ability to memorize the input and output mappings. Okay, so option C is your right answer. Okay, network capacity is basically how many distinct patterns can be learned and recall, or you can say memorize. So option C is the correct answer for this particular question. Let's move on to the next question. Okay, question number 93. What terms describe the scenario where the training error of a model decreases while the test error increases? Okay, listen carefully. What it is saying, what term describes the scenario where the training error of a model decreases while the test error increases? Okay, so let's see the one by one the option. Option number D, proper fitting. This both errors are low. Okay, so this is not the right option. Testing error, a metric. A testing error is a metric, but it can't be suited as a behavior. This is also the wrong option. Underfitting, both errors stay high. In this underfitting, both the errors stay high. Model fails to learn the patterns. So this is also the wrong option. Your right and correct answer is overfitting. Okay, what happens in overfitting is the model memorizes training data but performs poorly on new or unseen data. Okay, that's why we are saying where the training error of a model decreases while the test error increases. Okay, so your correct answer for this particular question is option number A, that is overfitting. Okay, underfitting, poor learning on both train and test data. Proper fitting, balance. Testing error, it is just a symptom. Okay, that's why your overfitting model learns training data too well, even noise, but fails on new data. Okay, so your option A is the right answer. Let's move on to the next question. Okay, next is, what is co-reference resolution? Okay, identify the definition basically. Option A, anaphora resolution. Option B, given a sentence or larger chunk of text, determine which word mentions refers to the same objects or entities. Option C, solution obtains through co-reference, and option D is solution of previous solved problem. Okay, now option D is clearly not the right answer as it is not related to NLP. Okay, option C, solution obtained through co-reference, unclear statement. Anaphora's resolution, anaphora is a type of co-reference. Okay, your correct answer is option number B, that is a given sentence or a larger chunk of text, determine which words refers to the same entities or same objects. Okay, so option B is your right answer. What is forward co-reference resolution means? Let's move on to the next question. Dash, question number 95. Dash is the type of morphology that changes the word category and affect the meaning. Okay, dash is the type of morphology that changes the word category and affect the meaning. Your correct answer for this is derivational. Option number B. What are the other options? First is inflection. Okay, doesn't change the class. Claticization, okay, deals with attaching short elements. Okay, so this is also the wrong option. Inflation, okay, it is basically typo or misspelling, not a valid term. Okay, so your correct answer for this particular question is derivational is the type of morphology that changes the word category and it affects the meaning of it. Okay, so option B is your right answer. Let's move on to the next question. Okay, question number 96. Consider the following statement. In the logistic regression model, we pass the values of W, x plus B for every x in the dot set. Okay, remember, for every x in the dot set, for a sigmoid function to return a parabolistic class label. Okay, and what is the second statement? Okay, second statement states in the logistic regression model, if the value W dot x plus b given to the sigmoid function in close to 0, then the class label predicted with a 0.5 threshold is very certain and reliable. Okay, so we have given this two statement with regards to what? With regards to the logistic regression, and we have to interpret this statement. First is logistic regression, okay, where we pass the values W dot x plus b through a sigmoid to return a probabilistic class label. And second is if W dot x plus b is close to 0, the class prediction is uncertain and reliable. We need to identify which one from the options, which one is true. Okay, so first statement is true. First of all, I will say this first statement is true. Okay, so let's, because logistic regression uses sigmoid W dot x to map outputs between 0 and 1. Okay, so logistic regression, that is your sigmoid function, gives output between 0 and 1, that is the probabilistic classes. Okay, you have two class labels, that is 0 and 1. Okay, so your first statement is correct. Coming to the next statement, when the sigmoid input, it is acting about what? Sigmoid function in close to 0. When your sigmoid function is near 0, the output is equivalent 0.5, which is least confident. It is least confident, not uncertain. It is least confident. We say it least confident, not certain. Okay, so this statement is wrong. Okay, so let's see the options. We have option number A, only one is correct. Okay, this is the right answer. Only two is correct. Wrong. Both 1 and 2 are correct. Wrong. Neither 1 and neither 2 are correct. Wrong. Okay, so your correct answer is option number A, that is only statement 1 is correct. Okay, so your answer A is correct answer for this particular question. Let's move on to the next. Okay, now fuzzification question. Question number 97. A journal fuzzy controller consists of what? Okay, this should be the easiest one. You should know what the journal fuzzy controller contains. Let's see the options. Option A, fuzzy rule base, fuzzy inference engine, and fuzzification and defuzzification modules. Option B, fuzzy function, fuzzy inference engine, and fuzzification and defuzzification modules. Okay, what is the change here? Here they have mentioned rule base, here they have mentioned functions. C, fuzzy rule base, fuzzy data engine, fuzzification and defuzzification module. And D, fuzzy functions, fuzzy data engine, and fuzzification and defuzzification module. Your correct answer is first one, that is fuzzy rule, fuzzy inference engine, and fuzzification and defuzzification methods are the part of the fuzzy controller, nothing else. Okay, so your fuzzy controller has three key components, that is, one is your rule base, second is your engine, inference engine, and third is your specification and despecification modules. Okay, so your answer option A is your right answer. Let's move on to the next one. Which of the following is not a correct encoding technique used in genetic algorithms? Okay, we need to identify which one of the following is not a correct encoding method used in genetic algorithms. Okay, options, let's see. Value encoding. See, value encoding is used when real numbers are needed. Option D is wrong. Okay, so when real number values are needed, then we use value encoding. Option C, binary, mostly used in GA encoding. This we used in GA encoding. Okay, chromosomes as bystrings. Okay, so this is also not the right answer. Next, tree encoding used in GP, that is genetic programming. Okay, so this is also not the right answer. The term that is not recognized in GP, or you can say genetic algorithm, is premier encoding. Okay, okay, the term is not recognized. Okay, we are aware with what? We are aware with tree encoding, we are aware with binary encoding, we are aware with value encoding. Okay, but the term premier encoding is not associated with what? GA. That is your standard GA literature, you can say genetic algorithm literature. Okay, so your option A is your correct answer for this particular question. Next. Okay, question number 99, again from neural networks. A neuron has 5 inputs given by I equal to 1, 2, 3, 1, 3, 2, minus 1 and 3, and corresponding weights that are given are 0.5, 2, minus 1, 2, and minus 0.5. The bias that has given to us is B equal to 0, and slope parameter alpha is given equal to 1. The sigmoid activation function is used to generate the final output Y. We need to identify the value of Y. Okay, so computed, first of all we need to compute the sum. Okay, so let's go step by step. First we will pen down what we have. Okay, we have the inputs given, that is 1, 3, 2, minus 1 and 3. Weights are respective weights are given 0.5 to minus 1, 2 and minus 0.5, and bias is given as B equal to 0 and slope equal to 1. Okay, let's see step by step. First we compute the dot product. Okay, so we will compute the dot product of weight and inputs. So the final answer that we get is 1. Next we will apply the sigmoid function, sigmoid formula, so that is equal to 1 upon 1 plus e raised to minus x, and x here we has as 1. Okay, just now we got the product 1. Okay, if we apply this, we will be getting something as 0.731. Okay, so your correct answer will be answer C, that is 0.03 will be the value of Y. Okay, you can go step by step. Simple. First you compute the dot product, then we applied the sigmoid activation function. Okay, so what we got? We got 0.731, that is equivalent to 0.3, that is your option number C. Okay, let's move on to the next and last question. Which among the following minimizes the upper bound of the generalization error and maximizes the margin between a separating hyperplane and the training data instead of minimizing the training error? Okay, so what it is saying, which of the following methodology minimizes the upper bound of the generalization error but maximizes the margin between a separating hyperplane and training data? Okay, so first one by one we will see. RBF, option number D that we have here, RBF, this option, what it states, it is a type of neural network, does not focus on margin explicitity. Next, option number C, we have Hopfield neural network. It is what? Recurrent network. Okay, use for associative memory. So this is also not the right option. Next, we have SVM. SVM is what? Support vector machine. Support vector machine. Okay, support vector machine, which is used to maximize the margin between the hyperplane and the data points. Okay, so this will be your right answer, that is SVM. Okay, it is used to maximize the margin between the separating hyperplanes and the respective training data points. Okay, and now what is this Boltzmann machine? It is nothing but a probabilistic method. Okay, so this is wrong. Okay, so your correct answer for this particular question is answer number B, that is SVM. Your support vector machine is used to maximize the margin between the separating hyperplane and the data points. Okay, learners, so with this we conclude our SET Computer Science 2024 PYQ paper. Okay, I hope you have followed all the previous three parts and do go through this part as well. Okay, more such PYQ videos will be shortly uploaded on the channel regarding SET as well as the UGC NET. So kindly do go through that as well. If you found this video or the explanation useful to yourself, do like, share and subscribe this particular video. Okay, thank you and Jai Hind.